Hi, my name is Corey Hinker, and this is my presentation on LabVIEW and the MyDAC using the RC and RL circuit to demonstrate the functionality. So I'm going to demonstrate two ways that you can get the data that you're looking for. The first one is actually using the instrument launcher and using the function generator and the oscilloscope. So I have the RL circuit wired up for capturing data. So you put your inputs here that you want for the function generator, and then your inputs here for how you want to record the data. So I'm going to hit run here on the function generator, and then I'm going to hit run on the oscilloscope. So you can change the number of pulses that you record by changing the size per time division, and for our sake I'm going to keep it here to record 1 or 2 pulses. You can run continuously, or you can run once and then it freezes it. I'm just going to leave it as run continuously and hit run again. Then I'm going to hit stop. You can do an edge trigger or just immediate, which will just trigger all the time. You can use the cursors to determine time differences from like start time, and then the voltage differences as well between the two channels. And then here it displays what the actual voltage is between the two. So channel 0 and channel 1. We can capture this data in a log by hitting this log button. I'm just going to put this into a test folder, and I'm just going to name it test. And it actually saves it as a TXT file. So in this TXT file, pulls in the data like this. Really not useful in a text file, but using Excel you can easily import that text file into Excel and use it to manipulate and graph as you desire. So in this test, let's run test folder. So within Project1 test, we're going to hit all files, and here's our test file. So it pulls it in as a delimited file. We hit next again, and we're just going to change the time ones to text, and it pulls the values in, and then you can do manipulation. So we don't want all this time information, so we can actually do a replace all, and so that way we only have the seconds information. And then here, not very useful, file format, so we're just going to hit Control Shift down to select the column, Control and then Control Shift down for that, and we can format those cells to a number with 7 decimal places. So there we have some useful data information, and if you want you can do Control Shift down on certain ones and graph as necessary and do your data calculations and find the point where it's 1RL, 2RL, 3RL, and so on. So that's the first way to get the data that we're looking for through the oscilloscope and the instrument launcher. I'm just not going to save for now, and so you can change what ways. You can use this any way you want with the MyDAC and wiring your circuit on the breadboard. So the next way, I'm just going to hit stop on here, is I created a waveform generator and capture through LabVIEW. So this is my front panel where you can select which type that you want, the different offsets that you want, etc. So I'm just going to hit run, and you see we recorded some data, or we captured some graphs. Now I'm going to show you how to capture data into a file. So I'm just going to name this test.tdms, which is the format that we want to record it in. And I'm just going to, if you want to record more than one wavelength, we can change that value and record more values here and with different pulses. So this is how it operates. You want to change values or record more, you just hit stop, you rerun it, and it pulls it in. And then you get this TDMS format. which with National Instruments you can do an open with and use this add-on for Excel importer, and it'll pull it into Excel, and then you can do your manipulation, and here's the data and an easy quick graph to show the functionality and show our graph, and you can manipulate the data as you want in Excel. So this shows multiple ways that you can use the tools for LabVIEW for conducting labs, either using the instruments provided for National Instruments or creating your own VI for conducting these types of experiments. Thank you for your time.